In this video, we're going to talk about 6.2, the kernel and range of a linear transformation. So the first problems here, we're going to be finding the kernel of a linear transformation. The kernel is all of the places where the transformation is equal to the zero vector. So for example, 3, here we have a transformation of R4 to R4, which is given as T of X, Y, Z, W is equal to Y, X, W, Z. So we want T of X, Y, Z, W to be equal to 0, 0, 0, 0. So that means that 0 equals Y, 0 equals X, 0 equals W, 0 equals Z here. So that makes my kernel the set of an X, Y, Z, W order here. It's going to be 0, 0, 0, 0, the 0 vector there in R4 is my kernel. Number 5 is transformation from P3 to R with the transformation defined as T of A0 plus A1x plus A2x squared plus A3x cubed is equal to A1 plus A2. We don't use A0, we don't use A3, we just use A1 and A2. So T of A0 plus A1x plus A2x squared plus A3x cubed needs to be equal to 0. It's just a real number, 0. So that means that A1 plus A2 has to equal 0, and A1 has to equal to negative A2. So we have our kernel is going to be A0 minus A2x plus A2x squared plus A3x cubed, where, and this colon means such that A0, A2, and A3 are all elements of the real numbers. Let's go ahead and look at number 7. 7 tells us that we have a transformation from P2 to P1 defined as T of A0 plus A1x plus A2x squared is equal to A1 plus A2x. So, I'm sorry, 2A2x. We've taken the derivative is what we've done there. That quadratic and gotten the derivative over here that's linear. So A1 plus 2A2x is equal to 0. And then that means that A1 has to equal 0 and A2 has to equal 0. We're assuming x is not 0 here. This needs to be 0 for all values of x. So this is 0 plus 0x. So a1 is 0 and a2 is 0, making a2 0. So my kernel is if we go back to the original up here, if a1 is 0 and a2 is 0, we just get the set of a0 such that a0 is an element of the real numbers. So just think of that if I want some polynomial over here that I want to take the derivative of and get 0, I better have a constant that I'm taking the derivative of to get 0. That's what's going on here, is I can't have any x term and I can't have any x squared term if I want to take the derivative and get 0. Let's move on to number 11. 11 asks me to find the kernel of t and the range of t that are defined by the transformation t of vector x is equal to transformation matrix A times vector x, where A is equal to 1, 2, 3, 4. So I have t of x bar is equal to A times x bar, where x bar is equal to x1, x2 here. So we have A x bar is equal to 1, 2, 3, 4 times x1, x2. And then I want this to be equal to x1 plus 2x2, and that's 3x1 plus 4x2, and that needs to be equal to the 0 vector there. So that means that x1 plus 2x2 equals 0, and 3x1 plus 4x2 equals 0. Let's multiply top equation left and right by -2. And that gives me -2x1 minus 4x2 equals 0. 3x1 plus 4x2 equals 0. That lets me know that x1 is equal to 0. If x1 is 0, then 2x2 equals 0, and x2 is 0. So my kernel is the set 0, 0. You just abbreviate that KER of transformation T is equal to set notation 0, 0, 0 vector there. So that was part A, to find that. Part B asks me to find the range. So one of the ways in which I can find the range is to take the original, to take the transpose of A, which is going to be 1, 3, 2, 4, and to reduce row echelon form that, and then to look at the row vectors that are left after this which would be my column vectors in my original. I'd be interested, but I'm interested in the rows of the transpose. So that's going to give me the range of T is equal to, and then the vectors are 1, 0, 0, 1, and those span R2. So that is my range, is everything that's in R2 can be made from this. So those are my entire possibility of outputs is everything in R2. Let's go ahead and look at number 13. And it has an A of 1, -1, 2, and 0, 1, 2. So my T of X bar is equal to A times X 2 by 3, so this needs to be 3 to be able to multiply it. And then that needs to be equal to, there needs to be 2 there. So this is a 2 by 3 times a 3 by 1 is going to give me a 2 by 1. Right. Okay. So this is x1 minus x2 plus 2x3 equals 0, and x2 plus 2x3 equals 0. So that is adding these, solving this here, that this one turns into x2 is a negative 2x3. So that tells me that I have x3 is equal to t, and this is a negative 2t. And so I have x1 is equal to x2 minus 2x3 is equal to t minus 2t. All right, negative x2 is negative 2t, and then minus another 2t is a negative 4t. So I have a kernel of t, which is equal to, and then I can take t out of these and get, let's see, x1 was negative 4t, x2 was negative 2t, and x3 was t. So this is negative 4, negative 2, 1 with such that t is an element of the real numbers. And another way I can express that is that that is span the set here, negative 4, negative 2, 1. So that covered part A. Part B asks me to find the range. So I'm going to take the transpose of matrix A, which is going to be 1, 0, negative 1, 1, 2, 2. I'm going to reduce row echelon form that, and I get 1, 0, 0, 1, 0, 0. Again, reading the row vectors here, not taking anything that's 0, 0. We're going to take range of t is equal to the set of 1, 0, 0, 1, which again is the same thing as R2. So look now at number 17. A is equal to 1, 2, negative 1, 4, 3, 1, 2, negative 1, negative 4, negative 3, negative 1, negative 3, negative 1, negative 2, 1, 1. And so t of x bar is equal to 1, 2, negative 1, 4, 3, 1, 2, negative 1, negative 4, negative 3, negative 1, negative 3, negative 1, negative 2, 1, 1. And times x1, x2, x3, x4 is equal to 0, 0, 0, 0 to find the kernel. So that gives me the equation x1 plus 2x2 minus x3 plus 4x4 equals 0. And 3x1 plus x2 plus 2x3 minus x4 equals 0. Negative 4x1 minus, let's just set it up this way. So you can see this is just a slightly different way to do it without writing all that. I can take A and augment it with this. One, 2, negative 1, 0, negative 4, negative 3, negative 1, negative 3, 0, negative 1, negative 2, 1, 1, 0. Then I can RREF that. And I'm going to get 1, 0, 1, 0, 0, 0, 1, negative 1, 0, 0. And I'm going to get 0, 0, 0, 1, 0. And I'm going to get a row of zeros down here. When I do that, so that tells me that x4 equals 0 right here, and x3 is equal to t, and x2 is equal to x3, so it's equal to t, and x1 is equal to negative x3, so it's negative t. So I have the kernel of t is equal to t times negative 1, 1, 1, 0, such that t is an element of the real numbers. Or I could write that as span of negative 1, 1, 1, 0. Now to find the range for part B, I'm going to take the transpose of A, which is 1, 3, -4, -1, 2, 1, -3, -2, -1, 2, -1, 1, 4, -1, -3, 1. And I want to, there's really no need to augment this. I want to RREF that. And I'm going to get 1, 0, -1, 0, 0, 1, -1, 0, 0, 0, 0, 1, 0, 0, 0, 0. And it's very similar, but a little bit different there. So we have that the range of t is equal to the set of, and it's these row vectors 1, 0, -1, 0, 0, 1, -1, 0, and then 0, 0, 0, 1, and ignore that row of zeros. Let's look now at number 19. '19 asks us to find the kernel, nullity, range, and rank of the given matrix. So A equals -1, 1, 1, 1. And that defines a transformation. T of x is equal to A x is equal to -1, 1, 1, 1 times x1, x2. And if we want the kernel, that's going to be equal to the zero matrix. Well, one way to get that is -1, 1, 1, 1, and augment that matrix here with 0, 0, RREF that, and we get 1, 0, 0, 0, 1, 0, like that. So that means that the kernel of the transformation T is equal to, this is x1 equals 0, x2 equals 0. We're talking about just the 0 vector there for the kernel. The nullity B is going to be the dimension. Nullity is equal to dim of the kernel of T. Basically, the question there is how many parameters does it have, like T and S and so on. So there's 0 parameters there, so it has dimensions of 0. So the nullity is 0. C is going to be asking me to find the range. I'm going to take the transpose here. And that equals -1, 1, 1, 1. I'm going to RREF that, and I get 1, 0, 0, 1, which makes my range of T equal to 1, 0, 0, 1, which is the same as R2. And then the rank of the transformation is equal to dimension of the range of t. We can see the dimensions here are 2. That's the number of vectors that are in the range here. So let's go ahead and look at number 21. And it is, A is given as 5, -3, 1, 1, 1, -1. And t of x is equal to ax is equal to 5, -3, 1, 1, 1, -1 times x1, x2. Yeah, is equal to 0, 0, 0. Right. So that makes this 5, -3, 0, 1, 1, 0, 1, -1, 0. Going to RREF that, and I get 1, 0, 0, 0, 1, 0, 0, 0, 0, giving me a kernel of t is equal to 0, 0, because x1 equals 0 and x2 equals 0. So the nullity of t again is 0. There's a dim of 0 there. At is equal to 5, 1, 1, -3, 1, -1. And if I want to REF that, I get 1, 0, 1/4, 0, 1, -1/4. And that's the same thing to me to get rid of these fractions as 4, 0, 1, 0, 4, -1. So I want to look at that and say that this is t times the column matrix 4, 0, 1 plus s times the column matrix 0, 4, -1 to make my range. So this is going to be my range of t is, and then this is going to be sorry, this is s and this is t. I mean, it really doesn't matter, but just so your answer matches what's in the book there, then this is going to be 4s plus 0t is 4s, and then we have 4t, and then we have s minus t, such that s and t are elements of the real numbers. So the rank of t is going to be equal to div range t, which is going to be 2, because there's two parameters, s and t there. And the rank plus the nullity should be the number of columns in matrix A. So we have an M by N matrix in A, nullity plus rank needs to be equal to N. So we had 0 plus 2 is equal to, this is a 3 by 2. So that's 2. So 2 is equal to 2. That makes sense. Let's look now at number 29. And it says, I want to do the same thing for matrix A is 0, -2, 3, 4, 0, 11. And let's find the kernel of this. So that is going to be 0, -2, 3, 4, 0, 11, 0, 0. Our REF is going to be, really doesn't reduce, they just kind of switch places. 4, 0, 11, 0, and 0, -2, 3, 0, which tells me that x1 is equal to -11 over 4, x3, and x2 is +3/2 x3, and x3 is itself, so it's the parameter t, and then I would like to pick it so that t is something here where it clears the fractions. So if I pick 4 here, I'm really dealing with a -11 times something, and a 6 times something, and a 4 times something, and that's an equivalent kernel where t is an element of the real numbers. That's my kernel of t. Right? And my nullity of t is how many parameters did I have there? That's 1. Transpose here is 0, 4, -2, 0, 3, 11. I want to RREF that. That's going to get me 1, 0, 0, 1, 0, 0, giving me a range of t of 1, 0, 0, 1, which is R2, and my rank of t is equal to 2. 1 plus 2 is 3, which is the number of columns in A. So that makes sense. Oh, I got my pages out of order, but that's okay. I'm going to do 25 now. A is 1, 0, 1, 0, 1, 0, 1, 0, 1. So to find the kernel of this, going to RREF that and get this is 1, 0, 1, 0, 0, 1, 0, 0. Then this is a row of zeros down here. So that tells me that x2 equals 0, x3 equals t, x1 is equal to a negative t. So I have kernel of t is equal to t times negative 1, 0, 1. T is an element of the real numbers. And that's the same thing as the span of negative 1, 0, 1. B is 1 for my nullity. Because there's one dimension there. A t equal to 1, 0, 1, 0, 1, 0, 1, 0, 1, which just so happens to be the same thing as A. So when I RREF that, I also get 1, 0, 1, 0, 1, 0, 0, 0, 0, which tells me that I have S times 1, 0, 1 plus T times 0, 1, 0. This is my range. T is equal to this. S and T are real numbers, but that's the same thing as the set of S 0 S comma S0 S 0 T0, which is the same as 0, 1, 0, 1, 0. All right. And so that tells me that this is D rank of T is equal to 2 because there's two dimensions, S and T here. See what pages there. Okay. Now we have 31. "31 says that A is equal to 2, 2, -3, 1, 13, 1, 1, 1, 1, -1, 3, 3, -5, 0, 14, and 6, 6, -2, 4, 16. And they designed this problem to be done with technology. I've been using technology all the way through. If you want a x, t of x equals a x equals all of equals 0, then we have 2, 2, -3, 1, 13, 0, 1, 1, 1, 1, -1, 0, 3, 3, -5, 0, 14, 0, 6, 6, -2, 4, 16, 0. Going to RREF that. And we get 1, 1, 0, 0, -2, 0, 0, 0, 1, 0, -4, 0, 0, 0, 0, 1, 5, 0, and then I have two rows of zeros here. No, a row of zeros here. 2, 3, like so. 4 rows, yep. So that tells me that x4 is -5x5, x5 equal to my t, and x3 is 4x5, which makes that 4t, and x1 plus x2 minus 2x5 is equal to 0. That makes x2 equal to s. So this becomes x1 is equal to -s plus 2t. I tried. They have all these variables the opposite of me here. So every time I think I get it figured out which way they want it, they change it up on me. So, all right. So my kernel of t is going to be t times, and then where are my t's? So -1, and then 1, and then 0, 0, 0, plus s times, and then I have 2, 0, 4, -5, 1, which makes this equal to 2s minus t, t, 4s, -5s, s, such that s and t are real numbers. And that makes this is A. B is what my nullity is 2 because I have s and t. And let's see here. So that was part B. Let's move on to part C. On the transpose of A, that gives me 2 2 -3 1 13 1 1 1 1 -1 down here, 3 3 -5 0 14 down there, and 6 6 -2 4 16 down this way. I'm going to RREF that, and I get 7 0 0 8 cross 0 7 0 20 0 0 7 2, and then 2 rows of zeros, giving me a range of t that is so this is 7x1 is equal to -8x4, 7x2 is equal to -20 x4, and 7x3 is equal to -2 x4, and x4 is going to be x4. So that's going to be 7s t. All right, so the easy way to do this is to read these down. The columns here, I don't think I've shown you that yet, but we have so RST is what I'm going to go for, that this is my row of R's, this is my row of S's, and this is my row of t's right here, and I'm going to read them down for my range. So this is 7r, 7s, 7t, and 8r plus 20s plus 2t, with r, s, and t being real numbers. And that makes the rank of t equal to 3, and 3 plus 2 is 5, and um, uh, we had 5 columns originally, so that's exactly what we should have. Let's look at number 35. '35 says finding the nullity and describing the kernel and range. So we're given that T is a transformation from R3 to R3, and the nullity of T is given. I'm sorry, find the nullity of T and give the geometric description of the kernel and range of T. So the rank of T is going to be equal to 0. And we already talked about nullity plus rank needs to be equal to the n of the m by n matrix. So it's got to be 3. So if the rank is 0, then the nullity has to be equal to 3. And so that makes the kernel three-dimensional, which makes it R3, and the range is going to be 0-dimensional, which makes it the 0 vector. Okay. Let's look at number 39. T is the projection onto the vector v equals 1, 2, 2. So T of XYZ equals, and then we're going to have the v is 2, 2. So I'm going to take the dot product of these, making these the coefficients of x, y, and z. So that's x plus 2y plus 2z divided by the magnitude of v squared. 1 plus 4 is 9. It would have been the square root of 9 squared, so that's 9 down here. And then times the vector 1, 2, 2. And if I want to find the kernel of that, so this is my transformation here of projection of uh, the projection onto the vector v here. And you can get that formula from Calculus 3 if you have a Calculus 3 textbook. Just look in chapter, I think it's maybe chapter 13 of the Larson Calculus textbook. This needs to be equal to the 0 vector here, which in 3 dimensions is going to be 0, 0, 0. So we have that's going to be that this part here with the x, y, z is the part that's going to give me zeros. So x plus 2y plus 2z has to be equal to 0. For me to get the 0 vector, I have to be multiplying this vector by 0. And the only way I get 0 is from this numerator. So that means that we have to have 2 free variables. So x is equal to, for instance, negative 2y minus 2z. So these are, say, s and t here, with s and t being real numbers. So two parameters or 2 free variables. So the nullity of transformation t is 2. The kernel of t is 2-dimensional, so it will be is a plane, and the rank of t is so we have rank of t plus the nullity of t is equal to 3. I have 3 columns, a column for x, a column for y, and a column for z. So rank of t plus nullity of t was 2. So rank of t is equal to 1. 1-dimensional. That means that the range of t is a line in R3. And the range of t will be if we want to figure this out, t, 2t, 2t here, with t is an element of the real numbers. We also write that as t times 1, 2, 2. Or you could write that as the span of one, two, two. And one last problem here, number 45. This is t of m to 4 to m 4 2. And we have that the rank of t is equal to 4. So we want to find the nullity of t. So we have rank of t plus nullity of t needs to be equal to the total dimensions of this space here, m to 4. So rank of t plus nullity of t is 2 times 4 is 8. So we have 4 plus nullity of t is 8, which makes nullity of t equal to 4. That's it for this video. We'll come back next time and talk about 6.3, which is matrices for linear transformations. So see you for the next video.